Unit vectors. Write each vector in figure in terms of the unit vectors I hat and j hat. So these are vectors A with magnitude 3.6 meters, making an angle of 70 degrees counterclockwise with respect to positive x-axis, and vector B magnitude 2.4 meters, making an angle of 30 degrees with the negative x-axis in the counterclockwise direction. Use unit vectors to express vector C, where C is 3a minus 4b. And part C, find the magnitude and direction of vector C. So let's start with part A. In order to express these vectors A and B in terms of unit vectors, we have to find their components on x-axis and y-axis, so we have to take the projections. And the projection of vector A onto the x-axis is A sub x, which is the magnitude of vector A times cosine of the angle it makes with the x-axis, cosine 70. So the magnitude was 3.60 and cosine 70. If you substitute for cosine 70, you will find that the answer is 1.23 meters. Now we can do the same for the y component. Y component is magnitude of the vector A multiplied by sine 70, and that's going to give us 3.60 sine 70, which is 3.38 meters. Now the same exercise for vector B. The projection of vector B onto the x-axis is minus b cosine 30. Why? Because the projection would be onto the minus x axis here. You can see if you take b cosine 30, you also have to include a minus sign to find the component. So this is going to give us minus the magnitude 2.4 multiplied by cosine 30, which is minus 2.08 meters. And y component, by, is minus b sine 30, which is minus 2.4 sine 30, that is minus 1.2 meters. So knowing the x and y components, we can express these vectors as vector A equals x component A sub x I hat plus A sub y j hat. So we can put these unit vectors here. This is a unit vector I hat, and this is unit vector j hat. So I hat points in positive x direction, j hat points in positive y direction, and magnitude 1. So ax I hat plus ay j hat becomes 1.23 I hat plus 3.38 j hat in meters. So this is vector A written in terms of unit vectors I hat and j hat. Okay, so let's put this in a box. Now for vector B, similarly, we can write vector B as bx I hat plus by j hat. Vector B is in the third quadrant, has two negative components, minus 2.08 I hat minus 1.2 j hat expressed in meters. So this is vector B written in terms of unit vectors I hat and j hat. Okay, now we will work on vector C. That is part B of the problem. That is 3 times vector A minus 4 times vector B. So vector C is 3A minus 4B. So this, if I substitute for A and B, the expressions in terms of unit vectors, 3 times 1.23 I hat plus 3.38 j hat minus 4 times minus 2.08 I hat minus 1.2 j hat. So vector C becomes 3 times 1.23 plus 4 times 2.08 I hat plus 3 times 3.38 plus 4 times 1.2 j hat. So if we do the algebra here, we will obtain 12.01 I hat plus 14.94 j hat in meters. Okay, and part C of the problem asks me the magnitude and direction of vector C. Well, if I know the x and y components, the magnitude is square root cx squared plus cy squared, which is square root of 12.01 square plus 14.94 square. So that is going to give me magnitude 19.17 meters. And as for the angle it makes with the x-axis, its direction, I note that first of all the x component of vector C is positive, the y component of vector C is positive, so it's in the first quadrant. Now tangent of the angle it makes with the positive x-axis is the ratio cy divided by cx, that is 14.94 divided by 12.01, that gives 1.24. So the angle theta is tangent inverse of 1.24, which is theta equals 51.2 degrees. Okay, so let's make this box again. All right, so the conclusion is that the vector C points in a direction that makes an angle of theta equals 51.2 degrees with the positive x-axis. All right, so let's summarize what we did here. So we are given two vectors A and B on the xy plane, as you can see in the figure. The first thing we did was to find the components of these vectors. Vector A component AX is A cosine 70, Y component A sine 70. Vector A is in the first quadrant. It has two positive X and Y components. So after that, we can write vector A as axi hat plus ayj hat in terms of the unit vectors I hat and j hat, pointing in positive x and positive y directions respectively. Now vector B is in the third quadrant. It has a negative x component and a negative y component, which are found by calculating b cosine 30 and b sine 30. And after writing these vectors a and b in terms of unit vectors, we can easily find vector c, which is 3 times a minus 4 times b, by substituting for vector a and b the expressions in terms of unit vectors, and we can calculate the magnitude of vector c since we know its x and y components, which are positive in the first quadrant. Square root of cx squared plus cy squared gives us the magnitude, and tangent of the angle it makes with the positive x-axis is cy over cx, and theta is 51.2 degrees, and we know theta has to be less than 90 degrees because it's in the first quadrant.